welcome with another video. I'm back again with something new, something more interesting and exciting for you, for my viewers, for my students, and for all those who are interested in spectroscopy. So let's talk about what is an IR spectrum. What is an infrared spectrum? IR is an abbreviation for an infrared region of a spectrum. So this is simply IR. It corresponds to infrared spectrum. So what is an infrared spectrum? Now simply, first of all, you should know what is infrared spectroscopy. So the infrared spectroscopic studies, it deals with the molecular vibrations of the compound, right? And provide essential data for their structural and geometrical features. Now they are also used for identifying different groups, that is functional groups and bonds that are present in your compound to be analyzed, right? The sample to be analyzed. They can find out through this great awesome technique, and you can find out, I mean, with its peaks, different peak heights. You can, the peaks are the characteristic of the specific functional groups that are there in that sample. So you can simply, if you in a IR spectrum, if you find out the specific peaks for OH group, as for example of a hydroxyl group, or for an aldehydic group, or for different other functional groups, you will be able to find out that yes, these are the characteristic peaks, and they are supposed to be on these wave numbers, right? Because the graph is plotted between percent transmittance and the wave numbers in centimeters. So I hope you will like today's video, because it's interesting, and it's it's a very important parameter when you synthesize, those who are going for organic synthesis. It's the second characterization that is supposed to be done by the chemist when you are dealing with the analysis of any compound, or you are characterizing any compound. So this is basically a characterization technique, right? A very useful, powerful characterization technique, and through this techniques you can find out different functional groups that are present in your compound. With the help of the different peaks, the compound will show you, the infrared spectrophotometer will show you it. You can easily identify that which functional groups are there, and it confirms the presence of if those functional groups which you are looking for in your unknown organic compound. You can easily, because you know, for your known organic compound or an unknown organic compound, you will be knowing that your compound, what is your compound's name, right, which you are analyzing, and what is its structure. If you know the name, you know the structure. That means then you know what bondings are there, which functional groups are attached to that particular compound, the bulkier groups, lighter groups, whatever functional groups are there. So you will find the specific peaks that will indicate the presence of those functional groups in that region, and from that you will confirm that yes, your compound is being synthesized, because you know the name of your compound when you're doing the synthesis. I'm talking about the synthesis. So you know that you are preparing a compound, and it has these ingredients in it, and now you are supposed to have these peaks in your graph, right, that is plotted so by this spectrophotometer. So this is one of the ways to confirm that whether your compound is formed or not. And it can also conveys you about the purity of the compound, because there are certain peaks which indicates the impurities, that there are impurities in your compound, right? So besides the other functional groups that are present there, right? So let's jump to this great lecture today, that what is an IR spectrum. I'm Professor Dr. Mchem from Dr.Mchem Institute of Chemistry, University of St. Joshua, and I'm here again with this awesome topic, and the topic I adore simply because I cannot move on with the characterization steps by avoiding this technique, right? I have to encounter this technique before I move on with other characterization techniques, because this is the most important important and most essential one if you are not, you have prepared the compound. The first step is you have prepared the compound, right? And now you are doing the characterization after the melting point, recording the melting point, the boiling point of your compound. Now the next thing is your CH analysis, that is carbon, hydrogen and nitrogen analysis in your organic compound, and what percentages are there in your compound, and then you send it for analysis to some lab, and then they send you back the percentages, and if they match, they should match, or they are very closer to one another, then of course you have some, a peace of mind that yes, my compound is, I have prepared the compound, and maybe it is, it is formed, it has been synthesized correctly. And then you go for the third technique, which is this this characterization technique, that is the IR, that is infrared spectroscopic studies. You go for these studies, and then you move forward with other characterization techniques. So let's start. What is an IR spectrum? What is an IR spectrum? So this is our today's very interesting topic. What is IR spectrum? Now, this is a typical infrared spectrum of any compound. It's just for your, your knowledge. I have plotted this. Now, the graph is plotted between percent transmittance and the wave number, as you can see in centimeters. And you can see the sharp peak, sharp and low, some high intensity and low intensity peaks. That is like these. These are low intensity peaks and the sharp peaks, right? In this spectrum. So this is simply the plot of transmittance of radiations. Yes, these are different radiations versus wave number of the radiations. Now in this infrared spectrum, you can simply see that some quantities are on the vertical side and some are on the horizontal side. So the quantities that are on the vertical side are simply the percent transmittance, and this is the percent of radiations that are falling on the sample, which is again falling to the detector. So the percent transmittance is the radiation falling on the sample, which is again falling to the detector. Now here simply a light source you can see, and the sample, again a light source and a sample. Now from this example you can follow my concept of this infrared spectrum. Now what is happening here? You can see a light source and a sample and an arrow that shows us that it's 100% transmitted. Now, what is this? This is it. Sample does not absorb radiation. That means the radiant light from the light source, and the radiations are passed, and then what happens that the sample, it does not absorb any radiation, resulting all radiations are transmitted, right? So what is the percentage of transmittance? 100% transmittance. 100% transmittance is there. Whereas in the second example, the same light source and the sample, it has zero transmittance. Why? Because sample absorbs all radiation and none is transmitted. So resulting what? A zero transmittance. Now you can see as none is transmitted, nothing is transmitted, resulting the zero transmittance. Whereas in the above example it was 100% transmitted. It was 100% transmitted. And because sample, it does not absorb the radiation and all the radiation was transmitted. Whereas in this case, sample absorb all the radiation and nothing is transmitted. So you got a zero transmittance, whereas here you got the 100% transmittance. So someone can ask you how you will be able to get 100% transmittance and how you'll be able to get a 0% transmittance. How can you distinguish between these two? So you can explain with the help of this simple example by drawing this very simple drawing, right, in which you are showing a light source and a sample and the percentage of transmission. Now here I would like to let you know that infrared, that is the electromagnetic. Now I'm explaining you something about the electromagnetic spectrum. The infrared, the X-rays, the infrared rays, the X-rays, the UV rays, the radio waves, the gamma rays, right? These are all the parts, elements of the electromagnetic spectrum. These are formed by swing, that is oscillating between what? A magnetic and an electric field. We know that these are simply formed by swaying or by swapping between magnetic or electrical fields, and these are known to react with matter via scattering or via absorption or via transmission, right? What? These are known to react with what? With matter via scattering, via absorption or via transmission. Infrared uses. Now, infrared vision goggles, right? The vision goggles used to observe objects, that is warm objects, okay? Those that are producing heat, warm objects. Now, IR imaging system is powerful. It's very powerful, and it is used or utilized to capture shots of houses at nighttime. They will spot the warm and cold areas, making it easier to find perfect insulation, right? So this is one of the ways that how they can insulate their houses by using this awesome technique. These are also used to track fires in forests and can also detect factory pollution, right? Because anything that is producing warmth or heat, it will be detected. Now, volcanoes, right? Volcanoes are monitored by IR satellites. What an interesting knowledge that volcanoes are monitored by IR satellites. Why they are monitored? Of course, because of the magma or the lava, that when it's gonna be erupted. So that's it. Eruptions in volcanoes can easily be detected by the source as top of the volcano. That is the top of the volcano. This top of the volcano, this is a volcano. Top of the volcano, it gets very hot, right, as it comes in contact with their surface. So due to of course the lava, the magma that is boiling inside it, and prior precautions or prior safety measures can be taken easily to avoid anything that is unwanted to be happen, right? So this is also one of the very interesting uses of this infrared spectroscopy and this infrared analysis. And I have shown you number of uses. There are many uses, there are multiple uses, but I have shown you only few, the most recent and most modern ones, which are nowadays being in the research journals, that these things are these are used to detect the fires, the heavy fires that are that can happen in any forest, and can detect simply the pollution anywhere, that is the factory pollutions, right? The factory, they produce a lot of pollutions, and of course then they gave us the example of the volcanoes, that they can be monitored easily by these simple that is by this powerful technique, and through the IR satellites. That of course the eruptions in the volcanoes can easily be find out by this source, right? And one can easily take precautions to prevent itself from some other serious consequences. So that's it. I'm sure that you like this short video today of what is an IR spectrum, what is an infrared spectrum, and because this is a very short this was a short video, I can explain you now the different regions of IR spectrum, right? The fingerprint region and the other regions. But right, I thought that I must first tell you what is an infrared spectrum and what uses an infrared spectroscopic studies can be provide us. How it can be used in our infrared simply light therapy is also a is a great treatment to overcome the pain, right, and the stiffness or the muscle spasms, and of course the inflammations. It can reduce the inflammations, and it can improve the blood circulation by simply the power of its specific wavelengths, right? And it's a unique treatment, right? That helps us in simply treating patients who have such, such diseases. Infrared physiotherapy is also one of the very, powerful technique to provide treatment or for treating the patients who have simply musculoskeletal pain. These are what type of pains? Of course, the pains in the joints and the spasms that are produced in the muscles, and so it helps to eliminate these pain-related diseases and these muscular spasms. And what is used for that? An infrared lamp is used for this treatment. So I hope you like this video today, as I have explained you few examples, and I've explained you the few uses of this infrared radiations also, and infrared. I've explained you what is an infrared spectrum, and how you can, if you are preparing an organic compound, how you can confirm the formation of your compound by simply looking for all those peaks that are supposed to be there in your organic compound which you have synthesized. So I hope I'm quite successful in explaining you this topic today, and you will like it, and it will work out for you the same way it worked out for my other students. Thank you very much. So I hope you liked today's video, as I've explained you, what is the infrared spectrum, and of course simply how much of, if you have 100% transmittance, why it is so, and if you have a zero transmittance, after the radiations are passing through the light source into your sample and you are getting zero transmittance, what is the reason behind it? And if you have 100% transmittance, what is the reason behind that also? And I've explained you the infrared regions, and I've explained you different the uses of infrared, and of course the infrared graph. I've explained you that it is plotted between the percentage transmittance and wave numbers in centimeters, and there are different peaks, right, that are specific for those specific functional groups that are present in your organic compound. And in this way you can find out the purity of your organic compound. You can use this infrared this technique for the treatment, also for the treatment purposes also. And I've explained you the few treatments in which it has been using since ages and ages. The infrared lamp, I was a small kid when I have seen the infrared lamp, so this is an old technique. I think now you are familiar how this infrared technique it works and it goes on. Hope to see you with something new, something more interesting, and something more exciting, which will definitely absorb your all concentration, and you will enjoy in learning. So let's be together again with another great video. Thank you very much.